Hi, this is Dave from Notes and Volts, and in this installment of the MIDI for the Arduino series, we're going to learn how to use multiplexers to add many controls to your Arduino board. Once again, I'd like to thank my Patreon supporters for helping to make this video possible. All right, let's get started. If you're new to this series, you may want to watch part 1 and part 2 of the MIDI controller video before you start here. To complete the experiments in this video, you'll need the following parts. Make sure you visit notesandvolts.com for the complete tutorial, parts list, program downloads, and more. I'll put a link in the video description below. In previous videos, we built up this simple MIDI controller using an Arduino Uno board. The Uno doesn't have a lot of inputs, which may be fine for a smaller controller, but what if you need more? To help us expand our controller, we're going to use a multiplexer. A multiplexer is a simple device that has multiple inputs that can be connected to a single output. A lot of these devices are bidirectional, which means you could also use it to connect a single input to multiple outputs. To determine which input is connected to the output, we'll need some control pins. Let's say we connect 8 buttons to our multiplexer. By changing the combination of signals on the control pins, we can select which input will be connected to the output. Next, we would take the output of the multiplexer and connect it to a single input pin on the Arduino. Finally, we'll connect each control pin on the multiplexer to an output pin on the Arduino. You can see how this greatly increases the number of devices we can connect to the Arduino. If we want to add more multiplexers, we simply need to connect the output to another Arduino pin, then connect the control lines to the same pins as the first multiplexer. So far, we've only used digital devices with our multiplexer, but a multiplexer can handle analog devices just as well. To connect some potentiometers to the Arduino's analog input, I would simply connect the output of the multiplexer to an Arduino's analog pin. Now that we know the theory, let's look at the actual devices we'll be using. First, we'll look at an 8-input multiplexer called a 744051. Let's look at how this connects to an Arduino in the real world. First, we need to find the pin labeled VCC. This pin provides positive voltage to the multiplexer chip. We'll connect this pin to the Arduino's 5-volt supply pin. Next, to complete the power circuit, we'll connect up the ground pins. The 4051 has 3 pins we need to connect to ground. The pin labeled GND is our ground pin. The next pin labeled VEE is our negative supply voltage pin. The 4051 is capable of handling negative voltage signals, but since we won't be using any, we'll connect this to ground as well. Finally, we have the E pin, which stands for Enable. If the chip is not enabled, it will not pass any signals from its input to its output. To enable the chip, we need to connect the E pin to ground. If we connect it to plus 5 volts, the chip will be disabled. Okay, so let's go ahead and connect these 3 pins to the Arduino's ground pin. Now that our multiplexer has power, we'll concentrate on the control pins. The 4051 chip has 3 control pins labeled S0, S1, and S2. We'll connect the control lines to pins 2, 3, and 4 on the Arduino board. We'll start with the S0 line on pin 2. The output pin on the chip is labeled Z. We're going to use digital buttons in this example, so we'll connect it to one of the Arduino's digital inputs. You can use any input from pins 6 to 12. Now we're ready to connect the inputs. The 8 inputs on this multiplexer are labeled Y0 to Y7. You may want to notice that they're not in numerical order. You can connect one button to each input the same way we would connect it directly to the Arduino board. Connect one side of the button to the input pin of your choice and the other side to ground. In this next example, we'll use the multiplexer to connect multiple potentiometers to one of the Arduino's analog pins. With the potentiometer facing you, connect the right-hand pin to +5 volts. The pin on the left will go to ground. Finally, connect the potentiometer's middle pin to any one of the multiplexer's inputs. The last step is to connect the output of the multiplexer to one of the Arduino's analog pins. Now we'll take a look at a larger multiplexer with even more inputs. The 744067 is a 16-input multiplexer. As we did before, we'll start by connecting the VCC pin to the Arduino's 5-volt supply. Next, we'll hook up the ground and enable pins to the Arduino's ground pin. Notice that the 4067 does not have a VEE pin. Now we can hook up the control pins. The 4067 needs 4 control pins to access all 16 inputs. We'll connect these 4 inputs to pins 2, 3, 4, and 5 on the Arduino board. Now let's take a look at the 16 input pins labeled Y0 to Y15. You can connect one device to each pin. Finally, identify the location of the multiplexer's Z output pin. If you're connecting digital buttons to the multiplexer, connect the Z pin to one of the Arduino's digital inputs. On the other hand, if you're connecting a potentiometer, connect the Z output to one of the Arduino's analog pins. One thing to remember is that a multiplexer can either be digital or analog, but it can't be both. Now that we know what we're doing, let's build up a test version of the circuit using real parts. We'll start by building the same MIDI output circuit we've used in the previous videos. All you need is a MIDI jack and a pair of 220 ohm resistors. Now I'm going to use a jumper wire to connect the 2 negative rails together. I'll do the same with the positive rails with a second wire. Next, I'll install a 4067 multiplexer with 16 inputs on the board. The pin 1 notch is pointed towards the left. Now it's time to add some buttons. Keep in mind that this multiplexer can handle up to 16 devices, but I'm just going to add 2 for this simple test. Now I'll connect the power and ground pins. First, I'll connect pin 24, which is VCC, to the positive rail on the breadboard. Next, I'll connect pin 12 to the breadboard's ground rail. Finally, I'll connect pin 15, which is the enable pin, to the ground rail on the opposite side of the board. Now I'll grab my Arduino Uno and connect the +5 volt pin to the breadboard's positive rail. I'll run a second wire from the ground pin to the breadboard's ground rail. Next, I'll connect the 4 address pins on the multiplexer to the Arduino pins 2, 3, 4, and 5. Make sure you get them in the right order. Now it's time to wire up the buttons. One side of the button will go to the breadboard's ground rail. The other side will go to inputs on the multiplexer. I'm using pins Y0 and Y1. Now I'll add a 4051 8-channel multiplexer to connect some potentiometers. The pin 1 mark is pointed towards the left. I'll start connecting this multiplexer by wiring the VCC pin to the positive rail. Now I'll connect the ground, VEE, and enable pins to the ground rail. Next, I'll connect the address pins. Remember that this device only has 3 address pins, so we'll connect these to pins 2, 3, and 4 on the Arduino board. Since the Arduino board already has wires in these pins, I'm going to steal the signals from the other multiplexer by bridging them with some jumper wires. Now I'll add 2 potentiometers to the board. Remember that this multiplexer could take up to 8, but I'm just going to use 2 for a test. Now on each potentiometer, I'll wire the right-hand pin to +5 volts and the left-hand pin to ground. Now I'll connect the center pin on one potentiometer to the Y0 input on the multiplexer. The second potentiometer connects to input Y1. Now going back to the 16 input multiplexer, I'll connect the Z output pin to pin 6 on the Arduino board. Now I'll connect the Z output pin on the 8-channel multiplexer to Arduino analog pin A0. And finally, I'll connect pin 5 on the MIDI jack to pin 1 on the Arduino board. The circuit is now all wired up and ready to go. Now it's time to program the Arduino board. Connect it to your computer with a USB cable. If you haven't already, visit notesandvolts.com to download the MIDI controller program pictured here. You also need to make sure you have the Arduino MIDI library installed on your system. We covered this in the previous videos. Okay, so let's configure the software for our MIDI controller. All we need to do is edit a few parameters to tell the program how we've connected our MIDI controller. Scroll down until you find the number mux buttons variable. Mux is shorthand for multiplexer. We're using 2 buttons in our project, so we'll change this variable to 2. We'll also change the number mux pots variable to 2 since we're using 2 potentiometers. Now scroll down to the Any Multiplexers section. Here we can describe our 2 multiplexers. I've included 2 example multiplexers in the comments section, so you can just uncomment these to use them. You need to create a mux object for every multiplexer in your project. Here's how you do it. Start the line with the keyword mux to indicate that this is a multiplexer object. We'll then give a name to each object. I'm using the names M1 and M2. Next, you write the number of the Arduino input pin that the multiplexer output is connected to. The next parameter indicates how many pins are on your multiplexer. Remember that a 4067 is a 16 pin and the 4051 is a 8-pin multiplexer. The final parameter tells the program if the multiplexer is connected to an analog or digital pin. Use true if it's an analog pin or false if it's a digital pin. Okay, so let's make the changes. We connected the 16-channel multiplexer to pin 6 on the Arduino, so we'll change that number. Everything else is correct, so we'll just uncomment the line to make it active. The second multiplexer was connected to analog pin A0, so we'll make that change. Next, scroll down to the Define Buttons Connected to Multiplexers section. I included a bunch of sample buttons in the comments. You can just uncomment them to use them. We have 2 buttons, so I'll uncomment the first 2. Here's how you describe a button. Start the line with the command word button to indicate that this is a button object. Now we'll give each button a name. I used MBU1 and MBU2. Next, we'll add the name of the multiplexer object that the button is connected to. We named this in the last step. The next number indicates the input number on the multiplexer that the button is connected to. We used input 0 and 1. The next number is the command parameter. This will determine what the button will do when you press it. You have 3 choices. Set it to 0 if you want the button to output a MIDI note command. Set it to 1 if you want the button to output a MIDI CC message. Finally, if you set the command number to 2, the button will output a MIDI CC message with a toggle function, which means that you have to push the button once to toggle the command on and a second time to toggle it off. The next number is the value of the note number or the MIDI CC number that you want the button to change. The next parameter is the MIDI channel number of the button. We'll set them all to channel 1, but they could be on different channels if you want. The final parameter is the debounce time of the button. You can leave this at 5. For this test, I'll just leave the parameters that were already set in the examples. To finish off our button, we just need to add the names of the new buttons we've created to our MUX button array. Since we're using the same names as the example, I'll just copy and paste them from the example code above. If you're typing this manually, you have to add an ampersand sign before the name of the button and then a comma between each name. Now scroll down to the Define Potentiometers Connected to Multiplexers section. Once again, I've added some sample values that you can just uncomment and use. To define a potentiometer, start off with the command word pot. Next, give each potentiometer a name. I used MPO1 and MPO2. Next, add the name of the multiplexer object that you created earlier. Remember, we called this one M2. The next number indicates the input number on the multiplexer that the pot is connected to. We connected ours to inputs 0 and 1. The next parameter is the command parameter. I left this in for future expansion, so right now just leave it at 0. The pots will only output MIDI CC values. So the next parameter describes the MIDI CC controller number that you want the pot to use. And the final parameter is the MIDI channel number you want the pot to control. Once again, we'll leave all the parameters as is for this test. Finally, we have to add the names of our pots to the MUX pots array. I'll copy and paste them once again. We have now finished configuring the software. Now go ahead and hit the upload button to send the program to your Arduino. You should get the message done uploading and no error messages in the lower window when it's complete. Now connect a MIDI cable to your breadboard. Connect the other end to the MIDI input of a device you want to control. I'm using the MIDI interface on my computer and some MIDI monitoring software to see the circuit in action. As I use each button and potentiometer, I can see the corresponding messages appear on my MIDI monitoring software. This lets me know that it's working. If you got this far, congratulations! You're now ready to add more buttons and more potentiometers to your MIDI controller. Alright, this concludes the MIDI for the Arduino series. I hope you've enjoyed it and learned something along the way. As always, visit notesandvolts.com for more projects and tutorials. And until next time, go make some noise.